Imagine standing on a planet where it doesn't just rain water, but diamonds. That's not just the stuff of sci-fi movies, it's what scientists think is happening deep inside the atmospheres of Uranus and Neptune. Think about this. Trillions of carats of diamonds, forming out of thin air, crashing down in storms unlike anything we've ever seen. But how can that even happen? And if it's real, why isn't anyone racing to collect these sparkling treasures? Stick around, because we're about to dive into one of the most dazzling phenomena in our solar system, and trust me, it's not what you expect. Let's set the scene. Uranus and Neptune are often called the ice giants of the solar system. They're mysterious, distant, and often overlooked compared to the flashier planets like Jupiter and Saturn. But beneath their bluish, icy exteriors lies a secret that has captivated scientists for decades. These planets are home to extreme conditions, pressures and temperatures so high that they could turn ordinary carbon into diamonds. And we're not talking about tiny flakes here. Scientists believe we're looking at massive chunks of diamond, falling like rain, sinking deeper and deeper into the planet's cores. Now, why does this matter? Well, it's not just about the glitter. Studying diamond rain could unlock secrets about how planets form, what's lurking beneath their surfaces, and maybe even give us clues about how to find similar worlds beyond our solar system. So, how do we know this is happening? And what does it look like when diamonds rain? These are the questions that scientists have been racing to answer. The problem is, we can't just fly a spaceship to Uranus or Neptune and collect some diamond rain for proof. These planets are over 1.5 billion miles away from Earth. Even if we could reach them, their extreme conditions make exploration almost impossible. Temperatures drop to hundreds of degrees below freezing, while the crushing atmospheric pressure would destroy any human-made probe long before it reached the depths where diamonds might form. And yet, scientists have found clever ways to simulate these conditions here on Earth. They've recreated the intense heat and pressure of Uranus and Neptune in labs, and guess what? They've successfully turned carbon into diamonds in the process. But there's a catch. Even with these experiments, we still don't fully understand how these diamond rainstorms actually work. Is it a slow drizzle? A raging storm? Or something else entirely? Let's break this down. Uranus and Neptune are made mostly of hydrogen, helium, and methane. Methane, as you might know, is a simple molecule with one carbon atom. When you dive deeper into these planets' atmospheres, the pressure increases dramatically. At a certain point, that pressure squeezes the methane molecules so tightly that the carbon atoms break free. Now, here's where the magic happens. Those free carbon atoms clump together and form diamonds, actual diamonds. And as they grow heavier, they start to sink through the planet's layers, creating what we call diamond rain. In recent years, scientists have used powerful lasers to mimic the extreme conditions of these planets. For example, in one experiment, researchers blasted a piece of plastic, which has a similar composition to methane, with high-powered lasers. The result? Tiny diamonds formed, right there in the lab. But while these experiments confirm the theory, they're just scratching the surface. The diamonds formed in labs are microscopic compared to what we think is happening on Uranus and Neptune, where these gems could be the size of pebbles, or even larger. So, where do all these diamonds go? Scientists think they don't just stop at the surface. Instead, they sink deeper and deeper into the planet's interiors. Over millions of years, they could form a layer of solid diamond, creating a glittering core. This leads to a bigger question. Could these diamonds tell us more about the planets themselves? Some researchers think that studying these processes could reveal secrets about how Uranus and Neptune formed, what their cores are made of, and even why they appear so different from other gas giants like Jupiter and Saturn. Here's the jaw-dropping part. The discovery of diamond rain isn't just about Uranus and Neptune. It's a window into a whole new class of planets called diamond planets. Imagine a world made almost entirely of carbon, its surface glittering with diamonds. Scientists believe there could be planets like this scattered across the galaxy. In fact, some exoplanets we've discovered already show signs of having high carbon content, making them potential candidates for being diamond-rich worlds. And if that's true, then diamond rain might not just be a curiosity of our solar system. It could be a common phenomenon in the universe, happening on countless planets we haven't even discovered yet. So, the next time you think about Uranus and Neptune, remember that these icy giants are more than just distant, cold planets. They're home to one of the most incredible natural phenomena in the solar system, diamond rain. From methane to glittering gems, these storms are a reminder of just how strange and wonderful the universe can be. And who knows? Maybe one day, we'll find a way to explore these planets up close, bringing back answers, and maybe even a few diamonds, from these sparkling alien worlds.